Hey there, it's me. And today we're going to explore the magic of shapes together. Can you guess what shape this is? What about this one? How about this? And finally, how about this last one? Pause the video here if you want to make a guess. The first shape is a triangle. A triangle has 3 sides and 3 vertices or corners. And your house might have many triangles in its roof. The second shape is a square. A square has 4 equal sides and 4 right angles or corners. The third shape is a pentagon. A pentagon has 5 sides and 5 vertices. The last shape is a hexagon. A hexagon has 6 sides and 6 vertices. Now, let's explore some fun facts about these shapes. Did you know that a triangle is the only polygon that can be made with straight lines? A polygon is a closed figure made up of line segments. Other polygons include quadrilaterals, which are 4-sided polygons like squares and rectangles, and octagons, which are 8-sided polygons. Did you know that a square is actually a special type of rectangle? Rectangles have 4 right angles, but they don't necessarily have 4 equal sides. Regular polygons are also known as equiangular polygons, because all of their interior angles are equal as well. So, for example, the sum of the interior angles of a triangle is 180 degrees times 3 minus 2, or 180 degrees. And the sum of the interior angles of a hexagon is 180 degrees times 6 minus 2, or 720 degrees. You may have noticed that it's pretty easy to draw a triangle, square, pentagon, or hexagon. These shapes are called regular polygons because they have equal sides and equal angles. It's actually quite hard to draw any polygons with odd numbers of sides that are both regular and convex. But if we allow ourselves the freedom to draw concave polygons, then there are actually no restrictions on the number of sides that we can draw. Look at this amazing star made up of 2,598 concave pentagons. This star was created by Tillman BCE and Paul Kenger in Basel, Switzerland in 2007. They started by drawing a regular convex pentagon and then continued to extend it outwards by adding more and more concave pentagons. In fact, there are exactly 5 times as many concave pentagons as convex ones. If we add up the number of sides of all the polygons shown here, we get 3, 4, 5, 6, 8, 101, 248. If we subtract 2 from this sum, we get 46. And look at this. 46 is divisible by 5. In other words, the sum of the number of sides of all regular convex polygons with up to 12 sides is a multiple of 5. Isn't that amazing? What about the sum of the areas of these polygons? If we calculate this sum, we get 1/2 times 3 times 1 plus 1/2 times 4 times 2 plus arfanji times wu times sem plus arfanji times lu times si plus arfanji times ba times wool plus arfanji times shir times lu plus arfanji times shir times t, which equals 215 halves. If we subtract 2 from this sum, we get 211 halves, which is not a multiple of 5. So it seems that the sum of the areas of regular convex polygons with up to 12 sides is not a multiple of 5. Let us try something else. Here are the sums of the areas of regular convex polygons with up to 12 sides, where we've included the areas of concave polygons. These sums are 351, 529, 777, 1025, 1273, 1521, and 1769. And you may have noticed that each of these numbers is a perfect square. In other words, the sum of the areas of all regular convex and concave polygons with up to 12 sides is a multiple of 1. Why do we care about these amazing patterns? As children, we learn about polygons by playing with building blocks. These blocks help us to develop our spatial reasoning skills and our ability to see objects from different perspectives. Spatial reasoning is important in many areas of mathematics, science, engineering, and art. Playing with building blocks also helps us to develop our fine motor skills and hand-eye coordination, and it's just plain fun. I'm sure you've had a lot of fun playing with shapes too. Thanks for watching. See you next time.